Hi, everyone. Thanks for coming today. So yeah, my name is Marcel. I'm a developer relations engineer at Google. I focus on Android and specifically on the system UI side of things. For example, last year, I was working on the new app widgets refresh that came in Android 12 with some of the new Material U and dynamic colors. Then we start working on a new framework to actually make building widgets and other Glanceables easier with Compose. So this is actually what I'm here today, to talk about how we can build these Glanceable surfaces with Compose. So first, let's talk about what is a Glanceable, right? According to the dictionary, it's some piece of information that can be displayed on an electronic screen, and it's easy and quickly readable. For example, the first thing that might come in mind are actually app widgets. Those are placed on the user home screen and display some sort of information of your application or enable some sort of quick actions. Those can be expanded then as well into other surfaces, for example, for the assistant or even on Android Auto. Not only on the phone as well, there are other Glanceable surfaces on Android. For example, last year, Wear OS announced the new Wear tiles. Those are tiles that comes in your watch that you can swipe through them to retrieve quick information or do some quick actions. So what is Glance then? Glance is the framework that we are building in order to create a common set of composables that, together with model-specific components, can build certain Glanceable surfaces. For example, one of them is the app widgets. Together with some specific platform components, you can define your composable UI using a Compose style code and Kotlin. And then Glance will wire everything for you and use the Compose runtime to actually translate this definition of your UI into the actual platform components. Those, on the case of app widgets, are remote views and XML. Similar for tiles, we create as well another module that will implement the common composables and expand it to some specific Wear tiles. Then, using the Compose runtime, we'll translate this definition into the actual tiles language and display on the Wear. We will be exploring as well other type of surfaces, but for now, we will mainly focus on this one. And for today, my priority will be talking about app widgets. Before I go further, I want to explain as well a bit the difference between Jetpack Compose and the Glance framework. As you might know, the Compose design is built on different layers that they are stacked on top of each other to create a more complete set of composables that you can use to define your UI. In the base layer, you have the runtime. This is the one that is used to generate the tree structure that will be used to then render the actual UI. Then the UI layer will offer you some capabilities like text, graphics, and so on that then the foundation is using in order to create the basic set of composables that defines your UI. On top of foundation, then you can build other type of layers that are more opinionated and define a more specific set of design, for example, with material layer. So Glance actually falls in between those. It uses partially the UI layer, and then it uses the runtime to actually translate its own definition of composables into the actual platform. So the difference between Jetpack Compose and Glance is that on Jetpack Compose, you're actually rendering on a canvas, and on Glance, you're actually just translating the definition of your composables into the actual platform components. That comes with certain limitations. For once, you cannot use other layers on top of Glance. You cannot use your foundation composables or material composables into Glance. And as well, there are a few things that still need to work, that it's like recomposition or side effects that we might support on the future. All right, so now that we have a bit better clear the concept between Glance and the actual Jetpack Compose, let's take a look on why we decided to create Glance. To do that, we will look into how we used to build widgets before. The remote view way, basically, will require you to extend the app widget provider. This is the interface between your application and the system to handle system events that request whenever a widget is placed on the home screen and needs to be updated. When the system requires you to update the widget, you would then create a remote view object. This object takes actual layout ID that defines the UI on XML. And then you can change some of these attributes at runtime by using the remote view API. For example, on this one, we are changing the text of the XML. The issue with that is that it's not type safe. So I'm actually saying that the greetings text should change to glance, but it does not tell me on compile time if this is actually a text view or not. It might change in the XML, and then we will have runtime errors. So it is really as well not the best API on the current modern Android development. Then, whenever you have this remote view created, you would pass it to the app widget manager and request the host to update the widget. Of course, then you still have to define your UI on XML that we all know that can be a bit tricky sometimes. On this case, it's just a simple frame layout together with the text view that it's centered on the middle. So now let's take a look at the same example, but how we could build it with Glance. We still need to define our provider to connect with the system events and tell it that we have a widget. But in this case, Glance framework handles all the lifecycle events and everything for you. So you actually need to only provide the instance of the Glance app widget that you want to use. So this instance then forces you to implement a composable function content. This is the entry point for your widget UI. Here's where you can provide your definition of the UI using Glance. On this example, we simply get the name that we want to display from the state, and then we display it inside a box that it's centered with the text. So one important factor here is that we don't have XML, and the API is way more readable, it's more easy to understand, and it allows you to customize everything at runtime and avoid some of the runtime issues that we would have with remote views. All right, so now that we have more clear overview on what is Glance, what we use it for, let's go into a more real-life widget. For that, we will implement a weather widget that we wanted to display the current location based on where we are, and that refreshes its data every 30 minutes. Let's assume for simplicity that all the data layer is already implemented. But we want as well to adapt it to multiple sizes. Widgets might have different sizes depending on the available size that the host provides to them. For example, a user on the home screen might decide to make it larger or to make it smaller. So we want the widget to adapt its content to that and display more or less information depending on the size. And of course, we want to use the new material U introduced last year on Android 12 to make the widget theme be dynamic depending on the wallpaper color. All right, let's go step by step. First, we need to register our widget with the system. And now you might say, hey, you said no more XML. All right, there's a bit of XML. We need to still define in the Android manifest that we have a widget. So we declare our receiver, and then we define certain metadata that is of this widget. Those are attributes that are defined here at the XML at compile time that will be used by the system to show a preview of your widget and to ensure that the size limitation that you specify here are respected whenever your widget displays on the home screen. For example, you can display a description, you can provide a preview image, etc. I will not go through all the attributes. You can read more about the app widgets documentation. And we will go back to our example. So now that we have registered our receiver, we need to implement it. To implement the receiver, as you saw in the first example, it's actually quite straightforward. We just need to pass the instance of our Glance app widget. We will create this weather glance widget that implements the content function that is our entry point to display the UI. In a nutshell, this is more or less the code that we will be using for our initial weather widget. Let's go one by one. First, we need to retrieve the actual state of the widget. So we want to get the weather information. And the Glance framework allows you to declare this to associate that into your Glance app widget instance. So every Glance app widget will have a state associated. I'm going to go into more details on this. For now, let's just assume that with this method, we are going to get the weather information that's available to display our UI. If we break down our widget UI, we will see that we have an initial row that contains our weather icon and the place where we are, and then another row that takes all the remaining space and displays the current temperature, the minimum, and the maximum. If you look at the first row, we are telling the content to just wrap based on the size of their children, and then expand to the max available size. Then, because the column respects the order you declare the things, whatever you place next, we are saying to fill the max size. So it will not take space from the first row. We will just take whatever is remaining there. It's really important to note here that I'm not using the Jetpack Compose column or row that maybe you're familiar with. Every composable that Glance uses are coming from the Glance model. So it's something that you need to take care whenever you are implementing Glance. We have some tools to make sure the IDE notifies you when you do that, but those are still a work in progress. All right, so now let's take a look at the first row. There are basically two components that we want to display, one at the beginning and the other one at the end. So to do that, one way would be to actually tell them that just share between you the available space. To do that, we will tell that both of them should take the max width, but assign it a weight. There is an easy method that is called default weight, that whenever all the children has a default weight, then a row or a column will share the space equally between them. On this way, we ensure that they both have enough space between them. As you might have seen, I'm calling other composable functions inside my content. Those are top-level functions, the same as you might have in Jetpack Compose, that you can declare and provide it as a top function to make it more readable and reusable. So you could actually reuse this weather icon in other places of your UI, or maybe another widget. This example is quite simple. We just have a box that takes the modifier, this pass, and then it displays an image by providing a drawable resource that comes from the actual weather info object. All right. So now that we take a look at the quick UI example, let's go into a more complex mechanism that is the state. So at the beginning, you remember I was telling you that we can get the current state of the associated widget. This is the concept of Glance, where every single Glance app widget will have a state. And it will have a Glance state definition that tells the system how to persist and read that state from the disk. Because widgets live on a different process, you cannot store things on memory. Because maybe when your widget is requested to be refreshed, your application process might have died. So you will have lost everything you store in memory. So Glance makes that simple by storing onto disk and allowing you to retrieve this information at runtime whenever you create your UI. To do that, it relies on another Jetpack library called Data Store to make it easy to handle the writing and reading from disk. And by default, it uses a definition called preference Glance state definition that will use the share preference. So it allows you to create a state with key value pairs and then retrieve those at runtime. If you have more complex objects that requires maybe a bit more complex data, you can still create your own state definitions by using proto-buffers and calling serialization. This is exactly what we need for our example. The weather information object, it might contain many different objects or classes that might be a bit difficult to store on a key value pair. So we will have to create our state definition. Basically, we tell which type of object we are going to use for the definition, and then we need to provide the data store object and the location of this data store. In our widget requirements, we want every single widget to display the current location. That means that even if the user plays multiple instances of the same widget, all will share the same type of information. Because of that, we can actually provide a single data store for all the widgets instead of providing one data store for each instance. So instead of using the file key that the API provides, we can just have a hard-coded name and a single data store object that will use our weather information serializer to know how to read and write into disk. This API is part of the data store, and in short, it basically requires you to provide a default value to be used whenever there is no data, and it tells you, and you need to tell it how to read and write into the stream. This is where we actually use the calling serialization, that you can mark your class as a serializable, and then use the serializer method to write this into, for example, a JSON string, or read from a JSON string. Once we have this implemented, we have our weather information state definition completed, and we just need to tell our widget instance to use it. To do that, we are overriding the state definition variable in our widget and tell it to use this object. So then whenever our content function is called, we can use you can retrieve the current state by just calling this method with the class that we use. All right, so now you have seen how the state mechanism work and how to read and write, but we as well need to update the state of the widget. We need to tell it, here's our data. To do that, I created this simple utility method that basically will retrieve all the instances that the user placed on the home screen and update its state. Because the state, as mentioned before, is shared between all the instances, we can update all at once. So we retrieve all the IDs, and then we tell the widget to update the data. To update its state, we can use the update app widget state, passing the definition and passing the glance ID. And then the update state lambda will allow us to modify the existing state, or on our case, we just can pass a full new object. This will be stored on the state of each of the app widgets and be used whenever we request to update the UI. OK, so this is how Glance manages the state, and you can store and retrieve the data and use that to build your UI. Now, the tricky part comes on when and where to actually refresh data and to request the data. To do that, let's take a look on how the different components of Glance are used. So we have our Glance app widget. This is the class where we define our UI on the content method. This content method is actually called by the system. Basically, whenever there is a required UI to be rendered, content will be called. And for example, if the widget is removed by the user, then onDelete will be called to clear things up. In addition, there is a public method called update that can be called from anywhere. It's a suspend function, so you should always call it from a coroutine scope. And basically, it forces a refresh of the UI. On top of this, there is our Glance app widget receiver. This is the class that handles all the lifecycle events, per se, that the system will tell to our receiver. And then it's important to understand that this receiver is underneath a broadcast receiver. So wherever you are doing on those methods will be inside the broadcast receiver scope. That means that you should not block that thread. All right, so let's take a look on how more or less the different events go. The first time the user places your widget into the home screen, on enable will be called. Then directly on update will be called to request your widget to update its content. Any subsequent calls to any subsequent widgets that the user places into the home screen will call directly on update. On enable will not be called again. If the user then remove all the instances, on disable will be called to tell you that there is no more widgets on of this type. In addition, there might be a system request to update your widget. That can come from example from the metadata attribute that you defined on your widget to update every specific period milliseconds. There is one more method that is handled on the receiver. That is whenever some options of the widget change. For example, the user resized your widget, the on-app widget options change will be called. And the framework might ask you to refresh your content. Again, all these four type of events are handled by Glance for you, so normally you don't need to take care of this. But it's important to understand all of them in order to know when you can refresh data. And of course, you have the mechanism to trigger it manually from anywhere of your application by directly calling update. So with this in mind, there are a few considerations. As you see, the content function of the Glance app widget instance might be called multiple times and actually from anywhere. And it's not lifecycle aware. It's just telling we need the definition of your UI, provide it. It is not possible to distinguish if the widget was placed for the first time or it's just a normal regular update. And as I mentioned, those updates might happen inside the broadcast receiver scope. That should not be blocked. So you should not place any blocking call, for example, fetching the network during the content function or in any of the lifecycle events that I mentioned. So what do we recommend is use the work manager. Work manager is the best way to actually schedule updates because it is not depending on if your process is alive or not. You can schedule and it will execute at some point following the system preferences. And it is easy as well to actually avoid that there are multiple workers enqueued at the same time because the content method might be called multiple times. You should really take care on that. And then as well, we recommend to be a good citizen, and there are many widgets on the home screen that can be placed. If all of them will try to update really frequently, that might cause battery drainage. So at least have a 30-minute window between periodic updates. And of course, if you have a data layer and your application is running, and then there's a database change that should affect the UI of the widget, because your process is alive, you can always then call update method from there, reflecting the UI directly on the widget. All right, so now let's get back to our example and take a look at the different components. As I mentioned at the beginning, regardless if we have multiple instances of our widgets placed on the home screen, they all share the same state. So for us, it's actually good enough to schedule our weather worker whenever the first instance of our widget is placed. So whenever onEnable is called, we will enqueue the worker. It will eventually execute, and in a different thread to get the weather information and update the weather widget state. We can schedule this periodically, so every 30 minutes, for example, we'll update the information. If more widgets are placed during this period, because they share the same state, they can just reuse the same data. So they will be able to display the information right away. And of course, whenever we don't have any more widgets on our home screen, we should ensure to cancel any periodic work that was scheduled. All right, so let's take a look at the code. This enqueue method will basically create a periodic request of every 30 minutes. You can add here things like network as well, preferences and so on. And then enqueue it using the unique periodic work. This basically forces you to define a unique work name and then a policy. The key policy, what it means is that if this method is called once, and there was no worker with the same name enqueued, it will enqueue it. If now there is this method call again, but this worker has not finished yet, it will just skip. It will not enqueue it. So this ensures that there is only one periodic work trying to fetch our weather information. And then, as I mentioned, you can just then override the on-enable or on-disable of your receiver to actually enqueue the worker to fetch the data. So now let's implement our worker. We will use the coroutine worker to first set the state of the widget to loading, for example, to tell the user that something is loading or refreshing. That can be done directly here from the same thread. And then we will make the blocking call to the network, that is the get the weather information. Once we retrieve this information, we call again the set widget state to update the state and the UI. All done through the same coroutine worker. Of course, if something goes wrong, we maybe want to display some error message and then benefit of the exponential backoff mechanism that Work Manager has to safely retry the worker. All right, so we have our widget that displays the current weather location. We have our mechanism to update its state, its information every 30 minutes. Now we want to ensure that the widget adapts to the multiple sizes that can be placed on the user home screen. We have first our smallest type of size that takes more or less 2 cells by 3 cells to display only the current day weather. But if the user would actually expand that widget to make it a bit larger, we maybe can add the hourly forecast. If the widget really has more space and want to get more information and expand it to actually be more large, we could maybe display the daily forecast. So how Glance works with sizes is with the concept of size mode. Depending on the size mode that you specify, the actual value of the local size you can retrieve on your content function will change its behavior. Let's take a look at the 3 different modes. The first mode is the default mode. It's called single. Basically, how it works is that whenever there is a request to update the widget content, it will pass the minimal size that you specified on the widget attributes. Those are the attributes that we defined at the beginning. So this is telling the system, I don't care the available space I have. I just want to ensure that the minimal space that I will have for my widget is this one. And if it changes the size, I don't care. The UI will be the same. So it doesn't change even if you expand the widget. Your content function is not called again whenever the user resizes, because the size value is not changing. So this is good to use. Whenever your content that you want to show, it's not size dependent. So you only have one single type of UI, and you don't really need to do like specific calculations based on the billable size. If you actually need to work with the, depending on the billable size, this is where you can use the size mode exact. This size mode exact, whenever the onUpdate method is called, it will extract all possible sizes your widget can be displayed. That means portrait, landscape, or for example, for foldables might be different modes, because depending on the mode of the foldable, the home screen might look different. So for all these available sizes, the content function will be called providing you the available size for your widget on the home screen. So whenever the user expands your widget or resizes, all over again, we'll do the same. We'll extract all the new sizes and call content again for each of these, allowing you to build a different UI depending on the available size. This is good whenever your content depends on the available size. Maybe you need to do some calculations to know if certain things will fit on the UI, or you want to display different type of widget. There is an important thing to note on this mode, that whenever the user resizes, the system needs to request you to provide the UI. So there is a delay, meaning that it will provide not so smooth transition, where there will be a moment where your widget UI might look a bit resized till the new value of the content comes in. This is where the responsive mode solves this issue. The responsive mode takes a set of sizes that you support. So you basically tell the system, OK, I support this size, the small one, and I support this other one, the large. Then when onUpdate method is called, content function will be called for each of the sizes you define. So first with size small, and then for size large. It will store wherever UI you defined on these sizes in memory, and then decide which one fits the best in the current available size. So if the user expands the widget, the content function will not be called again. Your UI was already rendered, was already created before. So now what the system does is, OK, I have more available space. Actually, the size large fits better. So let's put that one instead. Creating a much nicer, smoother transition, and avoiding, of course, to call content all over again every time the user resizes. This is good whenever you have a well-known defined set of sizes, and you don't need to do special calculations based on the available size. All right. So now that maybe we understand a bit better how this size mode works, as we talked before, we have 3 types of widgets that we want to display. So it's a well-defined set of sizes. So the best thing we can do is actually use the responsive mode by providing the size small, the medium, and the large. For readability purposes, I recommend you to kind of define them on maybe a top object or like a variable like here. And basically what we are saying is that, OK, if you have at least 140 by 120 DP size available, use the small mode. Instead, if you have at least 220 to 200, use the medium. And if you have even more space, actually use the large mode. Then the content function will be called for each of the sizes you defined. So we can use a when statement to provide a different UI based on the size. All right. So that is how you can actually create different UIs based on the size. And now let's put some color into this widget and use the new 112 material hue. This new material hue allows you to actually use a color palette or a color theme that is extracted from the wallpaper. Not only that, is extracted for where the widget is placed on the wallpaper. So the predominant color, wherever the widget is placed, will be used to define, for example, some of the background color or some of the accent colors, like, for example, for our icons. When it comes to widgets, though, the mechanism to use this dynamic color, it's a bit more tedious. The issue is that there is no callback whenever the user changes between light or dark mode, or whenever the user changes the wallpaper or puts your widget in a different place of the wallpaper. So your widget UI will not know that. That means that the color must be resolved by the launcher. The launcher should define dynamically which is the right color based on an ID. So this is why you should use color resource IDs instead of the actual color value, because otherwise the system will not be able to recreate, to use the dynamic colors. Unfortunately, that means that we then still need to define our colors through XML and provide a different color ID based on the resource type. So for example, for normal values, whenever it's a dark mode, so at night, or when the API is at least V31, that means that supports dynamic colors, we'll be then providing a dynamic color resource ID. Those IDs are retrieved from the material component for Android, and you can use it like that. So then in your composable function, you can use the resource ID that is shared, and the system will determine which color to use based on the light dark or the wallpaper color. We are working on a better way to do that by providing a similar concept the material theme from Compose has, where we will do all these more tedious work and resource IDs underneath. So you just need to declare that you use the Glance theme, and then the colors will change for you. It's not there yet, but we have an initial implementation on the sample that it's available on the GitHub repository. And that's it. Now we have our weather widget that can be resized to different sizes. It's smooth, and it changes the color theme based on wherever you place it inside the widget wallpaper, inside the home screen wallpaper. All right, that's it. You have the exact code I show here and the updated sample for the Glance version of the app widget into the official repository. We don't have yet guidance for Glance. Glance is still on alpha, so it's a bit too early to provide an actual guidance. But you can check out the actual app widgets guidance. It provides many core concepts that you might need whenever you build for Glance. And of course, we welcome feature requests or issues into our issue tracker. Ask your questions, Stack Overflow, or of course, you can ping me on Twitter if you want to know more. All right, thank you very much, everyone. I'm happy to take some questions, and we will as well be on the booth tomorrow at morning on the Android booth to talk more about Glance if you have any more questions. Thank you.